Our indoor air is filled with pathogens that we can't see. We breathe them in, and once inside our lungs, they start to damage our bodies. Of course, the pathogen that most people are talking about right now is SARS-CoV-2, which is the virus that causes COVID-19. In addition to that virus, there are many more viruses that are transmitted in the air. Those include the measles, influenza, and the rhinovirus that causes the common cold. One of the things that all these viruses have in common is that they're smaller than 0.3 microns. This is the symbol for a micron. They're 25,400 microns in an inch, so because they're so very small, we need an electron microscope to see viruses. When talking about air purification, you often hear about 0.3 microns because HEPA filters are rated to capture 99.97% of particles larger than that size. Viruses and nanoparticles, which are particles that are smaller than 0.1 microns and are hazardous to our health, and VOCs, which are dangerous gases, need special systems in order to remove them from the air. Your best bet for removing virus-sized and smaller particles is a filter, like our C-HEPA filter, that is rated to remove 99.999% of particles down to 0.003 microns. To remove gases, including VOCs and odors, a high-capacity activated charcoal filter is needed. But to achieve real peace of mind, you can use a multimodal air purification system that combines a C-HEPA filter, a high-capacity activated charcoal filter, with a hydroxyl radical generating system. Hydroxyl radicals are called nature's detergent. They break down pathogens while they are still in the air. Hydroxyl radicals are generated naturally in the upper atmosphere. Their function is to get rid of pollutants when they reach the upper part of the troposphere, which is the part of the atmosphere that's closest to the Earth. A hydroxyl radical is one atom of oxygen and one atom of hydrogen. With just one more hydrogen atom, it becomes a water molecule, H2O. And it desperately wants to become a water molecule, so it steals hydrogen atoms from wherever it can. The easiest place for a hydroxyl radical to steal hydrogen atoms is from organics that are in the air. Although hydroxyl radicals are generated naturally in the upper atmosphere, there are techniques that we can use to artificially generate them at ground level. For example, the Titanium Pro unit generates hydroxyl radicals by exposing titanium dioxide to high-intensity UV light. Using this technique, we can generate hydroxyl radicals to destroy pathogens in our indoor air spaces. In addition to being able to inactivate viruses and bacteria, they can also neutralize allergens such as pollens and mold spores. Organics in the air, like viruses, bacteria, VOCs, pollens, and mold spores, are all made up of molecules that have lots of hydrogen atoms, linking the atoms in the molecule together. When a hydroxyl radical steals the hydrogen atom away from a molecule, it breaks the links from that hydrogen atom to other atoms and weakens the molecule. That makes it easier for other hydroxyl radicals to steal even more hydrogen atoms, breaking more links. When enough of those links break, the molecule unravels. Why is this important when dealing with viruses? The surface of our cells is covered with receptors that are doorways through which things that are necessary for the cell can be brought inside. But each of these doorways has a lock. If a molecule, such as an enzyme, has the right key, it will be pulled inside the cell. If it doesn't have the right key, it will be kept outside. Viruses have evolved to mimic keys to fool the receptor doorways into allowing the virus to come inside the cell. Once inside, the virus takes over the cell and uses the cell's resources to make more copies of itself, which is what we call an infection. The spikes of a virus are protein molecules. If the virus spike's protein molecule unravels, it changes shape. If the key is the wrong shape, it can't open the lock and the virus can't get in. And so, the virus can't infect us. In addition to inactivating viruses and bacteria, by unraveling molecules, hydroxyl radicals can destroy gases such as methane and other volatile organic compounds. VOCs, volatile organic compounds, are dangerous gases that are harmful to people, especially when they're concentrated in indoor air. Sometimes you might see the abbreviation TVOC. That just means total volatile organic compounds. So, why do we care about VOCs? Exposure to VOCs can lead to some significant health hazards. Immediate hazards include eye irritation and other vision problems, respiratory problems, headaches, dizziness, and even problems with your memory. Long-term hazards include problems with the brain, with vision and hearing, problems with lungs, heart, liver, kidneys, and the digestive tract, as well as skin problems. VOCs can also contribute to leukemia and neurological problems, including loss of coordination, and can lead to fetal development problems in pregnant women. Obvious sources of VOCs include gasoline and diesel fuel and other petroleum-based products. But there are many products in your home and office that are also sources of VOCs. For example, air fresheners, your furniture and carpets, the office supplies you use, your printer toner and ink, paint, solvents and varnishes, detergents and softeners, disinfectants and cleaners, nail polish, candles, insect repellents, perfumes, and even the clothes you've sent out for dry cleaning. We know that VOCs have a direct impact on health. What kind of impact and how large that impact is depends on the type and the concentrations of the VOCs in the air we are breathing. Anything over 0.3 milligrams per cubic meter is generally considered to be damaging to human health. We have examined how hydroxyl radicals can inactivate and break apart viruses, bacteria, VOCs, and even nanoparticles in the air. But there are some limitations to what they can do because of the very nature of the hydroxyl radical. Hydroxyl radicals very quickly break down airborne particles, but each hydroxyl radical can only take one hydrogen atom from one molecule. As a result, to break apart an organic molecule, multiple hydroxyl radicals are needed. When the hydroxyl radicals crack the organic molecule or protein, it will eventually break it down into water molecules, carbon dioxide, and other smaller molecules. The problem with needing multiple hydroxyl radicals to break down each molecule is that in moderately dirty air, there are more than 83,000 virus-sized and smaller nanoparticles per cubic centimeter of air. That means in a 600 square foot room, there could be nearly 11 trillion nanoparticles. Unfortunately, the hydroxyl radicals can't just be targeted to the viruses in the air, so you need to have enough of them launched into the air to take care of all of the nanoparticles. Using hydroxyl radicals alone to take care of all of the airborne particles in a 600 square foot room, it could take as many as a quadrillion hydroxyl radicals. To truly be effective in destroying organics like viruses that are floating in the air, hydroxyl radicals need to be paired with high-efficiency filtration to significantly reduce the number of particles and gases in the air. Reducing the existing particle load in the air will allow the hydroxyl radicals to attack those particles that have not yet been removed from the air, and they will be able to attack viruses that are newly launched into the air by coughs and sneezes. So while hydroxyl radicals are not a miracle solution to removing viruses from the air, they are a great tool to add to high-efficiency filtration systems. To learn more about how Airgle combines the high-efficiency C-HEPA filter, a high-capacity premium activated charcoal filter, and the Titanium Pro hydroxyl radical generating module into a multimodal solution for virus, bacteria, particle, and VOC removal, visit airgle.com.